In just a few seconds, the ground beneath us can turn into a force more powerful than any storm. Entire cities crumble. The earth splits open. And yet, it all begins miles below our feet. What exactly causes the planet to shake so violently? Today, we're diving deep, literally, to uncover the science behind earthquakes. The Earth's outer shell, the crust, isn't a single solid piece. It's broken into massive slabs called tectonic plates. These plates are always moving, though incredibly slowly, about as fast as your fingernails grow. Think of it like stretching a rubber band. It can only hold so much tension before it snaps back. This process is called elastic rebound, and it's what triggers most earthquakes. There are thousands of fault lines across the planet, and they're most active where tectonic plates meet. The edges of the Pacific Ocean, known as the Ring of Fire, experience about 90% of the world's earthquakes. Types of faults and quakes. Not all earthquakes are created equal, and the type of fault determines how the ground moves. 1. Transform faults. Here, plates slide past each other horizontally, like the famous San Andreas Fault in California. The motion is side to side, and these quakes can cause major surface ruptures. 2. Convergent faults. At convergent boundaries, one plate dives beneath another in a process called subduction. These produce the most powerful quakes on Earth, like the 2011 Japan earthquake. 3. Divergent faults. At divergent boundaries, plates move apart, creating new crust. You'll find these mostly under the oceans, like along the Mid-Atlantic Ridge. Together, these three fault types shape mountains, form ocean basins, and remind us that our planet is always evolving and never truly still. So, how do scientists actually measure an earthquake? They use instruments called seismographs, which record the vibrations in the ground. The shaking creates wave patterns, and those tell us how big the quake was and where it started. The magnitude of an earthquake measures the total energy released. You've probably heard of the Richter scale, though today we use the moment magnitude scale. It's logarithmic, meaning each whole number increase represents 32 times more energy. Meanwhile, intensity measures how strongly people feel the shaking on the surface. It depends on distance, depth, and local geology, which is why a magnitude 6 quake can cause chaos in one city but barely rattle another. By combining data from hundreds of stations worldwide, scientists can pinpoint the epicenter, estimate the depth, and even send early warnings, sometimes just seconds before the shaking starts. Let's look at some real events that show just how powerful and unpredictable earthquakes can be. 2011 Japan earthquake, magnitude 9.0. In March 2011, a massive undersea quake struck off Japan's coast. The force shifted the entire island nation by over 2 meters, triggering a devastating tsunami and the Fukushima nuclear disaster. 2010 Haiti earthquake, magnitude 7.0. A year earlier, Haiti experienced one of the deadliest quakes in modern history. Shallow, close to a densely populated city, and with weak infrastructure, over 200,000 lives were lost. 2004 Indian Ocean earthquake, magnitude 9.1. This undersea quake near Sumatra triggered tsunamis that reached 14 countries, killing more than 230,000 people. It was a grim reminder of how connected our planet's forces truly are. Every day, the Earth experiences thousands of tiny quakes, most too small to feel. But when the big ones strike, they reshape landscapes, history, and human lives. Earthquakes remind us of the raw power beneath our feet, a force that has shaped continents and carved mountains for billions of years. While we can't stop them, we can prepare for them. Stronger buildings, better early warning systems, and global cooperation can turn devastation into resilience. The ground may shake, but our understanding keeps us steady. Thanks for watching. If you found this video informative, give it a thumbs up. Subscribe for more science stories. And remember, the Earth is always moving, even when it seems still.